Hello, everyone. My name is Peter Herrmann. I'm the first of three undergrad students from Cal Poly who are going to be talking about an open source project. We're trying to bring a RISC-V core to tape out on a Sky 130. So I'm the core design and verification team lead there, and I'm just going to talk about some lessons we learned in a organization strategy that worked for us for building pipeline logic. So at a high level, pipeline designs can be thought of in terms of some high-level properties. These properties are things like the number of stages in your pipeline, the placement of hazardous features in the pipeline. These are like reads, writes, data mutations, things like that. As digital designers, we love to get really into the optimization way too early. We like to focus on hyper-optimizing for goals like maximum frequency or like power and area long before we know what's actually important. But it's really important to realize that we don't actually know which of those goals are the most important until we've done some analysis down the road. We've gotten code profiling back and things like that. Yeah. Oh, geez. Sorry. So what I like to do is like really lean into the iterative process, basically focus on making your design really testable and iterable early in the process rather than focusing on any of those specific goals, and making an effort to identify those pipeline properties really explicitly so that when you write your top level modules, you can write them parametrically to work for any valid combination of those modules. To help with that, it's nice to have like a code structure that supports a clear separation of concerns, because it sounds really complicated to do that the first time. So I like to do a 3-layer hierarchy for pipeline logic. So at my bottom layer, I have simple combinational logic. It's trivial to test these modules. They make generous assumptions that the data going into them is valid. And they're unlikely to be broken across pipeline stages, so they can be moved around. The middle layer, this encapsulates the timing. So it basically, you put each of the stages into a middle layer and have a register at your output to capture the timing throughout that stage. It does the connective tissue between the combinatorial blocks. And the middle and bottom layers make absolutely no assumptions about hazards outside of those modules. So it makes testing these much easier. At the top layer, we have basically the connection between those stage modules. This is also where we have all of our hazard routing and all of the common resources and the actual external interface. All of the centralized modules that are written at this stage, this is where you actually have those pipeline parameters captured explicitly. So when you're writing these, you basically want to make that, oh, I'm out of time. Sorry. That's it. Yep, thanks.